Section 3.9 is at page 278, talks about an antiderivative. So we've been finding the derivative all along, given a function. We learned all of these tricks. Now we're going to undo that. In this class, we barely touched on that, but that's the bulk of the next course. To really get an idea of undoing a derivative, well, I start with first a derivative. If f of x equal x squared, then the derivative of this, f prime of x, would be 2x. And if f of x happened to be x squared plus 5, the derivative is actually 2x plus 0, that's the same thing. And if I take f of x to be x squared minus 4000, for example, f prime of x will turn out to be 2x. So, the derivative of x squared is 2x, the derivative of x squared plus 5 is 2x, the derivative of x squared minus 4000 is 2x. Well, guess what? What if I told you now, hey, given f prime of x equal 2x, can you tell me what f of x is? Well, think about it. Those three are the same, but those are not. So you would say, well, okay, I know all of them have one thing in common. You would say f of x must have had an x squared, but it could have had x squared plus 0 or 5 or negative 4000 to compensate for the constant, since the derivative of a constant is always 0. Every time you take an antiderivative, you have to write plus c. If there was nothing there, then c will be 0, and that's the end of it. Done. That's the idea. So, if I look at this definition, that's what it's saying. It's saying a function capital F of x is the antiderivative of a small f of x if you take a derivative of this, and you will get that. So take a derivative of what I got. If you take a derivative of x squared plus c, guess what you'll get? 2x. So, and this is the official theorem. If f is an antiderivative of the book uses, at least for now, this capital F small f correlation, meaning given f of x, if you take f prime of x, you will get little f. That's basically it. They say every time you take an antiderivative, you're going backwards, you have to pick that plus c. Now I'm going to give you the rule of thumb just like we did in taking a derivative. And this is worth memorizing. We're going to use it on almost most of what we do. And this is true for power functions. If f of x happen to be x raised to some power, where n is any number other than -1, then capital F of x, which is the antiderivative, to undo a derivative, remember how we brought the power down, subtract 1 from the power. To undo that, you add 1 to the power, divide by that. Don't forget the plus c. Now I would like to look at some examples. I'm looking at page 282. And let me start with the first problem. Suppose this is the function. If I want to figure out the most general antiderivative, I would say f of x would be add 1 to the power, 2 plus 1 is 3, divide by that, minus 3 you ignore, add 1 to the power, divide by that, plus, what do you take a derivative of to get a 2? Wouldn't that be 2x? Or you could think of 2 as the equivalent of 2x to the 0. And when you take an antiderivative, don't you add 1 to the power, divide by that? That works as well if you really want to apply that rule. But normally when we have a constant for a derivative, that means you take a derivative of a linear function. Same deal with number 4. capital F of x would be 6x, add 1 to the power, divide by that. The negative 8 you leave alone, add 1 to the power, divide by that, and add 1 to the power, divide by that. And that would be x to the 6 minus 8x to the 5th over 5 minus 3x cubed plus c. And it turns out taking a derivative is a lot quicker than finding an antiderivative, meaning if I take a derivative of this, I should get that, and if I take a derivative of this, I should get that. And you can check that really quickly. Now, to really get trig out of the way, trig is a bit annoying, especially the negatives. You write down the derivatives. Remember, you're working backwards. So when you're thinking what do you take a derivative of to get cosine, it's positive the sign. Here, it would be wise to write this out. So every time you're taking an antiderivative, you gotta really think in terms of those. First, I'm gonna write this as 3x to the negative 1/2. So when I take an antiderivative, that would be an x plus twice. And what do I take a derivative of to get sine? It has to be the negative cosine of x. Plus, add 1 to the power, that's 1/2, divide by it. And since we have a lot of fractions coming up, you should start practicing, instead of dividing by a fraction, multiply by the reciprocal. So multiply by 2 over 1, that's 6x under a radical plus c. And if I take a derivative of that answer I just got, I'll figure this out really quick. So again, taking a derivative is very quick and efficient. Antiderivative is a different story. Alright, number 12. It would be wise to write this as x to the 2/3. And this is x to the 1/2 times x. That's x to the 1 plus 1/2, which is 3/2. So f of x would be, add 1 to the power, 2/3 plus 1 is 5/3. Divide by that. Again, it will be wise to start multiplying by the reciprocal right away. Plus, add 1 to the power, that's 5/2. Divide by 5/2, that's multiplying by 2/5. You could leave the answer like that. I really don't mind. And for this problem, it would be wise for you to split this up. Say that's 5 over x to the 6 minus 4 over x cubed plus 2x to the 6 over x to the 6. So we could say g of x is actually 5x to the negative 6 minus 4x to the negative 3 plus 2. And if I find capital G of x, that would be 5x to the negative 5. Add 1 to the power, divide by that, minus 4. Add 1 to the power, that's a negative 2, divide by negative 2, plus 2x. Don't forget the c. So that's going to equal, those cancel out, negative 1 over x to the 5th plus 2 over x squared plus 2x plus c. You could get a common denominator if you wish, but that's fine. The rule of thumb is, if you started the problem with negative powers, you could leave your answer with negative powers. Since we didn't start the problem with negative powers, we need to go back and eliminate the negative powers. Now, every now and then they want us to find c. To do that, what they do, they give us a point on the graph. So let me elaborate. This point right here says, in the original function, when x equals 0, y equals negative 6. So to find the antiderivative, we'll say f of x is, add 1 to the power, divide by that, twice. What do you take a derivative of to get sine? Negative the cosine of x plus c. So f of x is actually x squared over 2 minus twice the cosine of x plus c. This is the general antiderivative. When they give me initial conditions, they call that an initial value problem. initial value problem. That means they gave us the initial values to find c, and all what you have to do is figure out y equal a negative 6 when x equal a 0. So 0 squared over 2 minus twice the cosine of 0 plus c. That means negative 6 equal negative 2 times 1 plus c. So c equals a negative 4. Take that out, put a negative 4, and there it is. Just to make it look nicer, you would want to say f of x equal x squared over 2 minus twice the cosine of x minus 4. This is a function in which you take a derivative, you get this, and if you throw 0 in initially, right there, you will get a negative 6. And the same idea could apply to something like 24, where you took two derivatives and ended up with a value. Well, if we take the first derivative, add 1 to the power, divide by that, add 1 to the power, divide by that, add 1 to the power, divide by that, oops, not an x, a 2, plus x plus c, right? And if you say, well, if I want to take another antiderivative, now, this is the variable. Add 1 to the power, divide by that, that will be 7 times 8, 56. Minus, add 1 to the power, divide by that, that would be 6 times 5, 30. Add 1 to the power, divide by that, that will be a 6, x squared over 2 plus. This will be a cx, and now you have to pick another variable for another constant, say d. And there it is. If I had 3 derivatives, this is t to the 1/2. So the first antiderivative will be add 1 to the power, divide by that, minus twice the sine of t, plus c. If you take another antiderivative, you'll get f prime of t. That is, add 1 to the power, divide by that. Well, 2/5 times 2/3 is 4/15 plus twice the cosine of t plus cx plus t. And f of t would be, let's see, add 1 to the power, that is 7/2. So multiply 4/15 by 2 over 7. Oh boy, that's 8. 535, 105. Plus twice the sine of t plus c, add 1 to the power, divide by that, plus dx plus e. So every time you take an antiderivative, you have to pick a constant. No exceptions. Alright, I'm almost done with this section, but not enough time to finish it with this video. I'll finish it with the next video. It's going to be really short.